Welcome to the deep dive. In a world where staying current feels like this constant uphill battle, just an avalanche of information, we're here to help you cut through some of that noise. Our goal is to help you genuinely grasp complex topics without feeling too overwhelmed. Today, we're diving deep into Spring Cloud Gateway in microservices. Now, our source material for this comes from some really clear excerpts distilled from Spring Cloud Gateway for Microservices, a beginner's guide. Our mission, pretty straightforward. Unpack what Spring Cloud Gateway really is, understand why it's so critical, frankly, in modern software, and see how it actually works with other essential tools. For a quick mental model, maybe think of it like the ultimate smart receptionist at a really, really busy office.
Yeah, and it's not just about the nuts and bolts, the technical stuff. We really want to show you how it functions, sure, but also the bigger picture. The architectural shifts, the real advantages it brings when you're trying to manage these complex distributed software systems. It's about seeing the strategic value behind the tech details.
Okay, so let's dig in. Spring Cloud Gateway. To really get it, though, we probably need to set the scene first. Microservices architecture. Right, so instead of one massive application doing everything, think like a giant online store all bundled together, microservices break it down. You get these small independent services. Each one does one specific thing. Maybe user logins or handling orders or managing the product list. They run on their own but talk to each other.
Exactly. They communicate usually through APIs. And that's precisely where Spring Cloud Gateway steps in and becomes, well, almost indispensable. It's built specifically for the Spring Boot world. And it acts as that single front door, that unified gateway for all the requests coming from clients trying to reach your microservices.
Okay, so back to that receptionist analogy.
Right. The client, maybe your mobile app or web browser, doesn't need the internal phone number for the orders department or user authentication. They just send all requests to the main reception desk, the gateway. And that receptionist, the gateway, it's smart. It looks at the request say for orders and knows exactly which service needs to handle that.
Gotcha. So it's doing more than just passing messages along. It sounds like it has some intelligence built in.
Oh, definitely. It's much more than a simple redirect. This gateway handles other really crucial tasks. It can, for instance, check security credentials on incoming requests, like a bouncer checking IDs. It can also manage the flow, limiting the rate of requests to stop one service from getting totally swamped. Or sometimes it can even gather bits of information from multiple backend services and package them up into one neat response for the client.
And it's designed specifically for Java and Spring Boot microservices, right? So it fits right in.
Exactly. It feels very native if you're already in that ecosystem. It centralizes these common tasks: authentication, rate limiting, routing, taking the burden off the individual microservices. This lets those services stay lean, focus just on their specific job. Plus, you get this single point for security and policy enforcement, which is huge for things like compliance audits, actually.
Right. That makes sense. A single entry point. Handling routing, security, rate limits, simplifying the whole microservice management headache.
That's the core idea, yeah.
Okay, so we've got a handle on what it is. But maybe the more compelling part is the why. Why did this become so essential? What problems was it actually solving in these complex microservice setups?
Yeah. The why is where you really see its value shine. I mean, think about a modern web app. It might need data from, 10, 15, maybe more different microservices.
Easily.
Without a gateway, that poor client app needs the exact network address, the specific API details for every single one of those services.
That sounds brutal.
Incredibly brittle and complex to manage. The gateway just smooths that all out. It simplifies client interaction massively by offering just one stable URL. The client talks to the gateway deals with the internal complexity. It's a huge win for the client-side developers.
Okay, so it makes life easier for the client apps.
Yeah.
But you also mentioned security earlier. It sounds like a big shift, putting security enforcement right at the front door.
Absolutely. Centralized security is a massive why. The gateway is your first line of defense. It enforces security rules right there. Like you said, checking authentication tokens, maybe verifying a JWT, which is just a standard secure way to pass user info, or applying weight limiting to fend off denial service attacks or just accidental overloads.
Okay.
And because it's centralized, the individual microservices don't all have to implement the same basic security checks over and over again.
That alone seems worth it. What about performance? Speed is always key.
Right. Performance optimization is another angle. The gateway can be Quite clever here. It can say aggregate data. Instead of the client making 3 separate calls to get user details, recent orders, and maybe loyalty points, the gateway can potentially grab all that from the backend services and combine it into one response.
Fewer round trips for the client.
Exactly. Fewer network requests usually means faster perceived performance. Plus, it can cache common requests. If lots of people are asking for the same product details, the gateway might cache that data and serve it super fast without even bothering the product service every time.
Nice. And you touched on load balancing too. How does that fit in?
Yeah, that connects directly to resilience and scalability. Load balancing is crucial. If your order service gets slammed during a big sale, you'll likely have multiple copies, multiple instances running. The gateway intelligently spreads the incoming order requests across all those healthy instances. It makes sure no single instance gets overwhelmed. It's like a traffic cop directing cars smoothly across several lanes.
Vending bottlenecks.
Precisely, which is absolutely vital for keeping the system up and running and for scaling smoothly when traffic surges. And one more big why, easier maintenance and updates. This is often underestimated. The gateway essentially hides the internal messiness of your microservices from the outside world. So if you need to update your user service, maybe move it to a new server or change its internal API slightly.
The client doesn't need to know.
Exactly. The gateway handles redirecting the requests to the new location or adapting to the change. The client application code doesn't need to be touched. This makes deploying updates, rolling back changes, and just general maintenance so much simpler.
Okay, yeah, that really pulls it together. It simplifies how clients talk to the system. It centralizes security and performance concerns, helps it scale, makes it easier to maintain. It's like the conductor of the microservice orchestra.
That's a good way to put it, yeah.
All right, so we understand the what and the why. Let's shift gears to the how.
Yeah.
What are the actual tools and, the specific features that work alongside Spring Cloud Gateway to make all this happen?
Okay, so at its core, Spring Cloud Gateway itself is, as we said, a Java library. It's built using Spring Boot and, importantly, Spring Webflux.
Oh, Flux.
Yeah.
That's the reactive part, right? Non-blocking I/O.
Exactly. That's key. Using Webflux means the gateway can handle a very large number of simultaneous connections very efficiently without needing a huge number of server threads. That's crucial for scalability in high-traffic situations. Developers basically configure it using routes. You tell it, for example, any request path starting with products. Send that over to the product microservice.
Okay.
And then you apply filters. Filters are where a lot of the magic happens. They're like little interceptors. A filter might run before the request is sent to the microservice, maybe to check for that JWT authentication token we talked about. Or it might run after the response comes back from the microservice, maybe to add a standard header or log something. You can chain these filters together to do things like rate limiting, security checks, request modification. Lots of possibilities.
And configuring this, is it complicated?
Actually, it's generally quite straightforward, especially for Spring developers. You can often do it in a simple configuration file like YAML or using Java code directly. It's designed to be pretty customizable, but also easy to get started with. Then there's the integration with Spring Security. That's a huge piece.
Right, the security framework.
Yeah, it plugs right into the gateway. So the gateway uses Spring Security's capabilities to handle authentication and authorization robustly. You can configure it to require specific credentials like OAuth 2.0 tokens or JWTs before letting a request through. And you can also set up rules based on user roles, like maybe only users with an ADMANA role can access any path starting with admin. It gives you fine-grained control.
And it leverages the existing Spring security knowledge base.
Exactly. Less new stuff to learn if you're already in the Spring world. It provides pretty solid security with relatively minimal setup. And the third key piece, especially for dynamic systems, is integration with Spring Cloud and service discovery tools. Think Eureka or maybe Consul.
So this is how the gateway finds the microservices, because they might move around or scale up and down.
Precisely. In a microservices world, instances come and go. Their exact network locations can change. Hard-coding those locations in the gateway configuration would be fragile. So instead, microservices register themselves with a service discovery server, like Eureka. They say, hey, I'm an instance of the order service, and here's my current address.
Okay.
And Spring Cloud Gateway then talks to Eureka. It asks, where are the currently available instances of the order service? Eureka tells it, and the gateway routes the request accordingly. This makes the whole system much more dynamic and resilient to changes. If you add more order service instances, the gateway automatically starts load balancing across them. If one instance dies, Eureka finds out, and the gateway stops sending traffic there.
That makes perfect sense. It decouples the gateway from the physical location of the services.
Exactly. It's vital for scalability and managing those constantly shifting environments. And again, because it's part of the Spring Cloud ecosystem, setting it up with Spring Boot applications is typically quite smooth.
Wow. Okay, so it really is this elegant combination. You've got the core gateway handling routing and filtering, then Spring Security layered on for robust auth and authorization, and Spring Cloud with service discovery, making sure it always knows where to send the request, even in a dynamic environment.
That's the package. Yeah.
And it all feels very cohesive because it's designed for that Spring Boot environment. The straightforward config, the powerful filters, the community support. It makes a strong case, especially if you're already invested in Spring.
Definitely. It fits very naturally into that ecosystem.
So, wrapping up our deep dive here,
Yeah.
we've journeyed through Spring Cloud Gateway. We've seen how it really functions as that central orchestrator, that smart receptionist, simplifying communication, beefing up security, optimizing performance across these sometimes bewilderingly complex microservice architectures.
Absolutely. And I think getting your head around this gateway pattern is, well, it's pretty crucial for anyone working with modern distributed systems. It gives you a really solid foundation for understanding how to build and manage these applications effectively, especially as they grow more complex.
So here's a final thought to maybe ponder. If Spring Cloud Gateway works so well as this intelligent central gateway for complex software systems,
Yeah.
what other complex ecosystems out there in the real world could use something similar? Think about, I don't know, logistics networks, maybe city planning, even just how humans communicate in large organizations. Could they benefit from a similar kind of centralized smart gateway to simplify interactions, enforce rules, and just generally manage complexity? Something to chew on. Until next time on The Deep Dive.